Let's solve LeetCode 39 combination sum. Given an array of distinct integers candidates and a target integer target, we want to return a list of all the unique combinations of candidates where the chosen numbers sum up to target. You may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. This is quite important. Two combinations are unique if the frequency of at least one of the chosen numbers is different. What is frequency defined as? The frequency of an element x is the number of time it occurs in the array. We know that. So the test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. So let's take an example 1. If the inputs is given as 2367 and the target is 7, the output is 223 and 7. Why? That's because if 2 and 3 are taken as candidates, you can do 2 plus 2 plus 3, which will give us 7. Note that, 2 is used multiple times here and 7 is also a candidate. So when you do it, you get 7 over here. Correct? You can just take one element, or you can take one element multiple times, or you can take one element multiple times and then another element. For example, 2 was taken 2 times and then 3. The same was done for 7. Only one time it was taken. It wasn't taken 2 times or anything because we reached the target just by itself. So use any combination of the candidates that are present in the array, how many ever times you want, just get the target, but there should not be any duplicate, right? So for example, by duplicate, I mean if 223 is present, 232 should not be present because the same thing is already covered. If the candidate is 235 and target is 8, we get 222, which is 4 times because 2 into 4 is 8. Then we have 233, which is 3 plus 3 plus 2, which is again 8. And then 3 and 5, which is again 8. So this is technically similar to the problem of threesome, correct? But the problem here is that we don't have a particular number of items. We don't particularly have 3 elements that will be present to sum up to 0. We have X number of elements and the same element can be repeated multiple times. So whatever we've learned in threesome problem cannot be applied here. So how do we think about it? Let me write down the array, which is the 2, 3, 6 and 7 array. The target here is 7, I believe, if I'm not wrong. Yep. So how do we do it? Well, this is a classic backtracking problem. How do I know it's backtracking? That's because I want to carry out all of the combinations with all of the other elements, including the element itself. So if we need to match something, we have to do 2 and 3, or we have to do 2 and 6, or we have to do 2 and 7, or we have to do 2 and 2 itself. And then we again have to find out what we have to do after every element that's selected. For example, we start off with an empty array. The target here is 7. Our goal is to reduce this 7 down to 0. As soon as we hit this target 0, we are done. So what is the first step we can take? We can go ahead and explore 2, right? If my array has 2, the target becomes 5. After that, I have a bunch of options I can select from, okay? I can again take in 2, I can again take in 3, I can again take in 6, I can take in 7. What will help me out? So first I take 2 again, so I get 2 comma 2 here, which gives me the target as 3, because initially I did 7 minus 2, which is 5, then I did 5 minus 2, which is 3, and then I do it again. So I have 2, 2 and 2, which gives me 1, correct, as the target. After that, I reach 2, 2, 2, 2, which gives me minus 1. Minus 1 is not equal to 0, so this 2, 2, 2 that we have is discarded. So if this 2, 2, 2 is not satisfied, what we do is, instead of taking 2 as the element again, we go ahead and try 3. So what will happen if 3 is there? Well, obviously again it will be negative. The same goes for 6, the same goes for 7. Okay, so none of them can be taken in. So what I do is, well, I go back to this particular array. All right. Now I try for, well, 3 again. So I get 2, 2 and 3. Remember, 2 earlier did not work out, but that's why we went all the way down and tried that combination. It didn't work out. So now we are taking the next element, which is 3. That works out, right? Because the target is 0 here. So we take this and append it to an array. Now what do? Well, I can just return from here. I found my solution. So I can just go ahead and try out 6. 6 doesn't work. 7 doesn't work. And then I come back over here. Okay. After that, I have to try out 2, 3, for example. That gives me 5. After that, I again try out 2, 3, 2, correct? And as soon as I find out 2, 3, 2, that is a solution. But the problem is we've already found out 2, 2, 3. Why do we have to again have 2, 3, 2? Correct? So we need to find out a way to ignore this particular element, and we'll figure that how to do. But essentially you get the approach here. We have to essentially have something like this. We have a target 7. Now we have multiple possibilities to take from here. 2, 3, 6, 7. So we try out one possibility entirely. Then we come back here. Then we try out another possibility here. Then another, and then another. So what will happen is something like this. For 2, we try out all the 4 approaches because that's the number of elements here. We'll try out all of the elements for each one of them and keep going until we find it out. And when will we find it out? Well, in the worst case, we will have to go through the 7 layers of depth. And for each one, there is 4. So what is the time complexity here? 4 to the power 7, correct? And that means our time complexity is O of, well, the number of branches that can be present. So that means the number of elements that can be present, which is M, let's say the length of the candidates, to the power, let's say N, where N refers to the number of, like, the tree's depth. That is what we'll have to do, because at every time we are having 4, 4 and 4, and we keep going. Okay. So that is going to be our time complexity. Let's get ahead and let's start coding it. So the very first thing is going to be to create a backtracking function. After we have the backtracking function, there's multiple things. The very first thing is what input parameters we're going to take. I'm going to take in, let's say, the path and the target. The target is going to be constantly updated. It's going to be subtracted from. And then I can just check that, hey, if the target is 0, we found out a solution. So let me create a result variable, and then I can simply do result.append, and then I'll just do path colon like this. We return out of this and we have our result. Now another thing, we notice that the target can be less than 0. If it goes less than 0, let's just stop it. It's a good optimization technique. So if the target is less than 0, let's just go ahead and return. I can't type return. Let's go. After that, what I want to do is find out, on an empty array, I want to go ahead and try out all the 4 approaches. So the very first is 2, then 3, then 6, then 7. How do I do that? I'll go over all of the candidates that are present in the array, correct? So I have candidate in candidates, and then for each candidate, I can call the backtracking function, correct? So I'll have path.append candidate. That's what I talked about. Then I just call the backtracking function like this, where I pass in the path and the target. The target is just target minus the candidate, correct? Just to recap, for the first thing we had 2. So our path was updated from an empty list to 2. So we appended. So that's what this line is doing. And then we called backtrack. Also, we updated the target, by the way. So 7 minus 2 was done, which gives us a target of 5. And after that, we want to backtrack again. On this particular thing, we want to find out all of the combinations that can take place. So what I'm going to do is call the backtracking like this. And then once everything is done, let's say we return out of it. So we are essentially going back to this function. What we want to do is get rid of this 2. That, hey, I was wrong. This is not the clear thing. Let's have a clear slate and start again. So I will just have path.pop done. Cool. So that will backtrack on everything and I can just return the result, and you might think that works, right? No, it won't work. Why? We didn't follow a particular thing that we had to do here. Let's take the array 2, 3, 6, 7 again. So I start empty. I'm just going down the 2 rabbit hole, all right? So I get 2, the target was 7, now the target is 5. Then I again go down 2, and then I again go down 2. So this becomes 3, then 1, and then -1, and I realize I'm wrong. So I go back over here, then I try out 3 over here, and we do get our response of 2, 3, 2, 2, and 3, because that's what we took, 2, 2, and then 3. That gives us our response. We appended that to our result variable. So result contains 2, 2, and 3. Cool. Now we try out other things. They don't work out. So what we do is we go up from here. All right. And I try out 3. Okay. So I found out 3. Now 3 can again go multiple places. It can again go to 2. It can again go to 3. It can again go to 6. It can again go to 7. Every element we have can go back from the beginning candidates array to everything, right? So now we get 2, 3, and 2. And that is not correct. Because if we append this to the result variable, which will happen, what we will have is a duplicate array. And we don't want to allow duplicates. How do we avoid it then? To avoid it, what we can do is, instead of just having a path and a target, we can also have a start index. Okay. Now what the start index does is that when you go from candidate to candidates, right? So you start from I is equal to 0, 1, 2, and 3. So let's say here you are at index 0. And then when you want to go to the next element, you say that, hey, we're not going to start with 0. We're just going to start with the next element. So we are just going to go through all of the elements at 3, because this 3 is at index 1, right? So what I'm trying to say here is that instead of starting at index 0 again, which we are doing every time, we're just starting from index 0 and going till the end. We can just say that, hey, we're going to start off from where this 3 ended. We are not going to go from 2 to end. We're going to start off from 3 to end. And if we are on element 6, we'll start off from 6 to 7 or 6 to end. We're not going to include the previous elements, because if we try to include the previous elements again, we will keep getting the same array, because, that's what happened over here. We had 2, 2, 3. We again got 2, 3, 2. The reason for it is because we always start from the very beginning. If we start from the beginning, we'll get the same indexes or the same arrays over and over again. So what I'm saying right now is that instead of starting from the very beginning, I can start from the current element that I'm on and go forward from that. So what I can do here is, for I in range, the length of candidates, and then I also have start index here. So instead of going from 0 to end, I always start from the start index, and the start index is going to be the current index that I'm on. Okay. So when I begin, which is when I call backtracking, my path is empty. My target is what the target is over here. And then my start is going to be the 0th index, because I'm starting from the second index. Okay. Let's start fresh again. So we have 2, 6, 3, 7. I believe that was it. Nope. 2, 3, 6, 7 was it. Cool. Now what I do is, we have something like this. I take in 2 and assume that I've done all the 2, 3, 2, all of those stuff. And now here I'm at index 0. Then I tried out 2. It didn't work out. Okay. So all of the 2s here did not work out. They did not work out, and each one of them had the start index of 0. But when I try here with 2 as which goes with 3, which is the second element, it's not at start index 0 anymore. It's at start index 1. How do we assign this value? Well, what I can do is when I call the backtrack function, instead of doing start here, which will just make sure that everything always starts from 0, I'll put in I. So what this allows me to do is, from I till the end, right? So this will give me access to 3. So when I'm over here, the first element of candidates is 2. We tried out all of the elements of 2. None of them worked out. So we go to the next element of 3. So the I is equal to 1 here. And then I only check from 1 till the end of the array. This will not give me duplicates because now if I have 3, I'm starting from 3. I'm never going back to 2. I can never go to 2 here, right? So 232 is not an option. It can only be 236, 233, or 237. We never go back to the previous element, and that's how we fix this solution. So let's go ahead, run it, and hopefully it works out. It doesn't. The reason for it is we don't have a candidate variable now. So let's create candidate, which is candidates at I. Let's run it again. And it works out. Let's submit it. And that works out as well.